Good evening. My name is Simbo Bright Samo. So I'll be taking us through the EDA presentation, PowerPoint presentation. So this is an EDA of EEG signal dataset for Alzheimer's disease and frontotemporal dementia prediction and detection using graph contrastive learning. So first of all, we have here a data set of participants data, and it has a feature of gender, age, group, and the MMSE. A minimum the MMSE. MMSE is like a mini mental state examination. So it's usually counted out of 30. So moving on. Here we have an example of a box plot for age and MMSE. So as you can see here, we have and the age of our box plot shows most of the people that we're having were between the age of 60 and 70. Yeah, and for the other one, for the MMSE score, well, we had our box plot showed most of them were lying between 20 and 30 as a score out of 30. Well, it's marked out of 30. So most of them were ranging between 20 and 30 out of the MMSE test examination. So moving on, we have another box plot here for MMSE, but divided into groups. We have three groups here. We have the people that are normal. We have the people that are normal. We have the people with frontal temporal dementia, and then we have the people with Alzheimer's disease. So with our box plot here, we see that most of the people with the people that didn't have any of the diseases were they scored 30 out of 30. Well, those ones with the disease were the Alzheimer's and frontal temporal. So we also notice that we have outliers here with Alzheimer, and the lesser the score, the more dominant the disease. Sorry, the more dominant the dementia is. We see that with Alzheimer, most people had the disease and the score was really low. And then here, now box plot for the people with frontal, well, they had a better score than the Alzheimer, indicating how how problematic Alzheimer is. So moving on, we have another representation of graphs, and these are histograms of data features. These data features, we are talking about the features that I talked about earlier, where we have gender, age group, and MMSE. So we have a histogram of age, whereby in our data set, the individuals that we're dealing with were majorly between 63 and 65, 62 and 65, and also those ones around the age of 70. And then for the gender, we had both male and female scoring the same number. And then for the groups, the people without are the people without is C, then frontal, then Alzheimer. Alzheimer were the most. And the biggest number here for the MMSE, we have a score out of 30 and a score out between 20 and 23. Yeah.
My name is Kawadasha Magezi from Group 5, and I'll be talking about filtering of the EEG signals. So the purpose for filtering these EEG signals is just to remove noise, which are the higher frequencies, those that are above 40 Hz, and just removing small, tiny frequencies that can account for like muscle movements, blinking, and things like that. And that's why we're having those that are between 1 and 40 Hz. Those that are above 40 Hz would be noise, those that are below 1 would be muscle movements. And further, we created an epoch plot in our EDA, and this is just to visualize the spectrogram of the EEG signals. And an epoch is just creating a small like a small period for which we can like visualize those signals. So we just chose a very small window of the signals to view. And as you can see on the screen now, we chose about till 19 seconds. And just for better results, we chose to reduce our epoch event to 2 seconds. And as you can see, our signal graph looks much cleaner. The spectrogram looks much cleaner, and we can easily uh, well learn from these EEG signals and be able to draw conclusions from them much more effectively. Then we did power spectral density um, on, our, on the EE signals, and this is just basically to to find those signals that have the most power and just to detect them. And as you can see, this is one of the output that we got from our code. And when we extract the PSD features, we saw that those that were between 0.5 to 4 were for very slow frequencies related to deep sleep, things like that. Theta was for those that are that were allocated to relaxation. Alpha was for calm and focused states. Then the beta was more for active thinking. The gamma was for high level cognitive processing and just people that are being very focused. So we were able to also produce a plot for the average spectral density of EEG signal frequencies. And this is what we got. Next, we are going to walk through our code and discuss it.
So this is our code. So we're importing libraries and we're importing the NumPy and then pandas, MNE, and we are also importing from sklearn. And then here we are loading the raw data into our code. Then here we are loading the participants data into the code. So next we are going to do box plots. We are going to write code for box plots for edge and the MMSE. So here we have a box plot for the edge, then we have a box plot for the MMSE, and then we are going to we're going to print out to display what we are working with. So within our display, we are going to have a column for the MMSE. We are going to have a column. We are going to group them, and then we're definitely eliminating the vertical, and then the grid. So here we are printing out. We are displaying the tight layout, and then show we are displaying what we are working with. We are displaying our data. So then we are also going to create graphs, histograms. We are going to create histograms for our data. We're going to have a histogram for age, gender. These are features of the individuals we have imported, we have loaded into our code. Then we're going to have a histogram for group, and then the MMSE as well. Then we are going to we are going to display what we have. We're going to display our data. And we're going to, okay, I'm going to call in my partner to take us through the next part, the remaining bit.
Um, um, Again, my name is Kaiwa, and I'm just going to talk about, well, starting from filtering the data. So we have a line here, and this line is a code raw.filter is going to filter our data to with a low frequency of 1 and a high frequency of 40. Then we shall have some events, and these are the events that we're going to create. In other words, the time that we're going to, the time periods that we're going to use to, well, to view our epochs, basically. And for this case, we want to use 2 seconds. And then we shall define our events uh, so that we can, visualize that portion of our epoch very well. Then we also create now an epoch from the spectrogram. And yeah, first we're going to plot the epoch, which was the spectrogram that was very crowded that we showed in our slides. And then secondly, we are going to plot the epochs which are zoomed in at 2 seconds, so we can see each line of the spectrogram accurately. Then obviously we're going to get into the PSD as earlier mentioned, and here we're going to just compute PSDs from our epochs. Then we shall we'll just keep the information, like the information of the power densities in the PSDs um, variable here. Then we'll collect the features, which is going to give us a shape of n epochs and n channels. And then we are going to we'll print out the shape. Then we shall plot. We shall then plot the epochs. And this is a graph that I showed in the slides. So yeah, we plot the epoch graph here, and this is just going to label our data, and this is just to show us a number of data of epochs and the number of data labels that we have. Here you can see that one will be assigned to every every even epoch will be assigned one, and uh, every odd, yeah, for every even one we shall assign it one, and every odd we shall assign it two. And yeah, that's just labeling our epochs, our epoch data. And that's yeah, that was our exploratory data analysis. And just to finish it up, this is our code. This is how it runs, and just to show us every single one of its results. There we have the box plots. Then we shall have the box plots by group, and we shall have the histograms. And after the histograms, as you can see here down here, did the filtering. Then we get to the epoch plot. Then this is the epoch plot. We are using the 2-second event. And then finally, of course, our PSD plot. Yes, that has been our EDA. Thank you.